Good morning, everyone. Thank you very much for the very kind introduction and for having me here this morning. I'm very pleased to actually have the opportunity to share with you our own journey here at Merck from manufacturing to smart factoring. So it's smart factoring, it's not smart manufacturing. And this is not a typo, this is an intent. It's not that we want to do smart manual work, we want to do smart work. That's why we call it smart factoring. And today I'm going to share with you our journey and what I've seen before, by the way, it's super impressive. However, for us, it's still a journey. And as if I say us, it's an industry. So I had a chance to have a couple of dialogues across peers, across industries, looking into where are we actually at the moment. And this might be different from industry to industry, from company to company. And what you see here on the screen is actually the sum and the summary of all of those dialogues. So let me double click a bit more on some elements. You hear about silos in organizations, especially if they're getting bigger and bigger. And my free interpretation of that is everyone is focusing on their work, and while you're focusing on your work, you don't know who needs access to the data. You just heard recently, how do we get access if you have 10,000 of people and more to access existing information? So you have data silos that you create. The next one is about fear towards AI and how AI is actually disrupting the way we work, while we have a massive workload and time and cost pressure. Incompatible technologies, though this is a big one. So Merck is a 350 years old company. And knowing that, it's also having legacy systems in place. On the other end, we have standards, or lack of standards, or maybe it's actually the opposite. We have too many standards. And those too many standards doesn't necessarily make it any easier and connect the different technologies. Different understanding of what digital is, or what smart manufacturing is, and the different views won't allow us to move in the same direction. The big data. I've been hearing a lot about big data. However, I've only seen a limited number of use cases that are not scalable or not scaled. And on the other hand, a lot of that data is still unstructured. Well, then the frozen information. Well, you know exactly that the data is there, but you still need to get access. You need to ask people. You have to do a lot of manual work. 80% indeed of the time of a data scientist is about cleaning data. Still the case, unfortunately. And something that is very close to my heart, the emotional response. So we're talking not about technology transformation. It's about emotional transformation. It's like asking someone to read a book on an electronic device such as a Kindle. You may not necessarily get the same emotional response. So thinking about it, it's not about buying a Kindle. It's not about getting a training on Kindles. It's about engaging emotionally to use a Kindle. And addressing that means also any kind of digital transformation that you have taken place is about taking people with you through that journey. So let me deep dive a bit more into what it means for manufacturing and manufacturing process development in the entire supply chain industry. So if you start from the beginning and looking at where you start in drug discovery all the way to manufacturing and commercial manufacturing, you see there are multiple different steps. And this is an example of how you produce an antibody. Very simplified, of course, but just to show you how many data, how many different experiments you have to run, and the complexity behind it, not only throughout those unit operations, but also about scaling those from small scale to large scale, from different technologies. You're transferring the knowledge from one lab to another, or to even to CMOs, to manufacturing. It's huge complexity. Then you're adding also developing analytical development methods to analyze the critical quality attributes of those products. On top, you're moving from non-GMP to GXP environment. So there's a lot of data, a lot of complexity that you're adding to one single product. Well, all of that to ultimately understand not only your process and the control strategy that you have to define, it's actually to define the critical quality attributes and to match them. Now, we know that this is, of course, not only about critical material attributes, but it's all about critical process parameters. And that is unfortunately not only within a single silo of a bioreactor, it's a holistic view on a process that gives you ultimately the critical quality attributes. So while this is already a challenge, we have a lot of data, different data. Right? From time series data, quality data, spectral data, images data, again, throughout all of the process, in the life cycle of the product, and throughout all unit operations. And ultimately, again, to understand the full complexity of your product. Another challenge that we face right now in the industry is the supply chain. So we see an increase in raw material cost, and that's getting worse and worse. We see the challenge of capacity management or inventory capacity management with increased waiting time for clearance of shipments, but also balancing those stock levels is a big challenge. We see also logistic challenges with cost of shipping of a container increasing 7-fold right now, and supply chain turbulence due to geopolitical conflicts. Unfortunately, this is still not changing, and it's actually getting worse. With the economic downturn, and with the macroeconomic conditions continue to change with potential for more downside. And we still have unpredictable demands. So while this is a challenge, how do you address that in a company? So if you look into laboratories and to manufacturing plants, it may have looked like that. And to be honest, I put these pictures into black and white, but honestly, if I put them into color, it wouldn't be any different today. Maybe, in some aspects. What really changed is what you've shown before, is the power of now introducing capabilities to leverage and to use that data to get deeper insights, but also about connecting holistically that data to generate the full understanding, not only about your product, but the entire life cycle of the product, including the supply chain. So how do we get there? So if you look into the evolution from manufacturing to smart factoring, it all started with process technologies, with production, purification, formulation, and fill and finish solutions, systems and flexware, unit operation connectivity, media development and formulation solutions. And we added more and more process analytical technologies to really get insights, real-time information through chemometric inline, at-line, and online sensors. We started sampling and to enable at-line testing, automated sample prep, and so on. All of this helped us to develop even more understanding about the processes. Now we're adding the so-called digital technologies with everything that you heard previously, but also all of those new capabilities actually learn how do we adapt that? How do we use it with the new ways or with existing ways of working? So the way we call it is actually to converge those technologies into what we call smart factoring. The convergence of those technologies will help us to drive or to enable autonomous manufacturing, supply chain intelligence, quality by design, and modular plants. Well, while this sounds super exciting, how do we get there? So at Merck, we came together as one Merck. That means every single business sector, including our colleagues from IT, came together to define what is our vision, right? Before starting anything, we wanted to talk about what is it exactly. Remember having one picture in mind? Where do we want to head? So this is what you see here is the result of at least 150,000 discussions. But all of this helped us to understand where we want to go. It really helped us to understand what the smart manufacturing platform is that you see here on the top. So first of all, we all agreed there's a big why we're doing it. And this is our customers/patients, everyone that we serve. Of course, while they are asking us to increase and to maintain the quality and reduce the cost and time to market, it's also adding something new here. We have here service in terms of service level and sustainability as something that is not necessarily new, but even more prominent today. And while this is all constraints and asked from us, we see that there's a lot of ways to get from R&D to process development to production to packaging, warehousing, transportation, and back to the customer, with a lot of possibilities to get externals in, CDMO businesses, partners, and so on. We also saw that all of the data streams are important to us, not only to create those digital twins and insights from unit operations, but to actually create something that we call decision intelligence, something that would help us to look at that holistically. With more and more access to external data and models, but also to create new business opportunities, which are very clear database business models. I'm going to show you some of those examples, and to create also software, which we also do within the life science organization. You see here some of those enabling technologies, PAT, IIoT, process technology or process science and technology, connected industrial equipment, so the convergence between IT and OT, OT standing for operations technology, and engineering and automation. And then we agreed on foundations. The foundations are quality and regulatory, as being key in anything that we drive in a regulated environment, cybersecurity, both IT and OT cybersecurity, end-to-end data management, standards, and people. And people being key in everything that we drive at Merck. So how do we get there? Let's look at where we are at the moment. So this is a benchmark that I got from a couple of peers across the industry. And we saw that 80% of all manufacturing companies are in a maturity level 2. So there are 5 maturity levels, level 1 as being on paper, and level 5 being fully predictive or adaptive plants, fully autonomous, self-optimizing plant, which might be a future. It seems like not many are there at the moment, and that most of them, of manufacturers, are within level 2. So if that's the case, what does it take? What do we need to do now to get from level 2 to level 3 and to the next? And does it actually make sense to level up all manufacturing plants and laboratories? Where do you start? What's the prioritization? What's the product? What's the investment? And what is it and what do you need to have in place to enable that transformation? So I had the pleasure to write a paper together with some colleagues from the World Economic Forum to actually see what are the 3 big enabling, what's the enabling framework basically. We saw that there are for sure technology enablers such as privacy and security, connectivity, data processing, data platform, data extraction. Then we see very key some organizational enablers such as having a strategy and a roadmap in place, governance and processes, ecosystem partnering, digital skills and capabilities, and legal compliance, and then many, many different application areas. Now let me double click now on the connectivity piece. IT, OT, so the connection, if you will, between the operations technology and the infrastructure and the IT landscape, it's absolutely key. If there's no standard, you won't be able to scale. You won't be able to create the fullest value of your application or any digital use case that you created. So that's why we have put this as our foundation. Having this as our foundation will be key to anything that we do at Merck. We agreed to work together on that aspect, cross-sectorally, together with the IT colleagues, making sure that everything that we implement will be one standard. That will help us to not only creating the respective data or operations data autobahn and respective ontologies, both process ontologies and data ontologies, but it will help us then to create those use cases that we are talking about advanced data analytics and predictive and prescriptive capabilities and automation. But you also see, we never forget about the people and culture aspect as being foundational across all of those dimensions. Reality is that the first foundation piece, unfortunately, is incredibly expensive. Reality is that there is not necessarily an NPV for building this foundation. However, we all agree that this is key. So to build the smart manufacturing layer or the digital transformation layer, you absolutely need to create this foundation. Otherwise, again, won't be scalable and you won't really create the value across the organization. So while DPT, the digital plant transformation, server hardware, data history, and so on is key, that will help us to build in the next layers with LIMS, MES, ALNs, and others, will help us then to build more and more of those use cases where the NPV will increase, so the digital maturity phases will increase as well. So I think this is key. It's good to know, and it's important to know while you're building your business cases and you're building your own digital transformation roadmap, your own journey. So we were asking ourselves, what happens if we don't do it? I mean, we're still producing a lot of drugs and products, so what happens if we don't do it? Well, let's have a look. So basically, at the moment, last year, the healthcare industry invested globally almost $14 billion only in smart manufacturing capabilities. The semiconductor industry, almost $23 billion. And over the next years, up to 2027, it's going to double for those industries. And you see that already 41% of global manufacturers are adopting smart manufacturing technologies. And for those who are investing into those capabilities already and creating their maturity levels and their impacts, they see already big results. They see an increase of labor productivity by 90%. They see the speed to market increase by 83%. These are pretty aggressive numbers. Now back to my question, what happens if we don't do it? I think you can answer that question for yourself. So it's pretty clear that there is not an option. It's mandatory. And if you want to scale those capabilities and generate this impact and making sure that you're doing things correctly, with all of the new investments, whether it's new CapEx investments, anything else, it's not about creating a lighthouse. It's creating a network of capabilities that you can start and share across the organization. Because there's no need of reinventing predictive inventories or predictive maintenance capability 3 times in an organization such as Merck or any other company. So, and there are millions. There are a lot of different capabilities in smart manufacturing and supply chain analytics, supply chain planning that you can do. And this is not comprehensive, just showing you a couple of those capabilities that you may have already heard: track and trace, or continuous manufacturing, predictive remote maintenance, real-time KPIs measurement, automated source agents. Beautiful, nice capabilities. I've been even hearing a lot about we should introduce VR and AR, right? All super fancy technologies. My question to the team is, which problem are we trying to solve? So what's the business problem that you're trying to solve? And where are we losing money? Where are we losing speed? Where can we improve quality? Where can we do? What should we do? Where are we in those business processes that actually needs attention? So that we can prioritize our efforts, that we can try to find where do we need to build that foundation, to actually build from that, to learn from that, and to scale further. So we came together as Merck again and asked ourselves, what are our priorities? We have 4 dimensions and that we looked at for customers, finance, employees, and society, and so that our priorities will help us to define our targeted KPIs towards everything that we do in smart manufacturing. So our priorities at Merck are definitely rethinking supply chains, is to have a greater focus on seamless engineering, plug and produce, automation, and IT/OT convergence, introducing more and more digital twins and AI-driven use cases to support new levels of resilience and flexibility, and increase workforce agility and amplify capabilities to enable resilience. And last but not least, as I mentioned before, to reflect regulatory requirements in an AI-enabled capabilities. So we are in very close contact with FDA, EMA, and other regulators to be in a dialogue. They are also learning and understanding how AI will change the way we do our products. But at the same time, we do. For example, as algorithms are changing over time, but they will be part of the submission, it will be interesting how every time that an algorithm will change, it will be part of a change of a product. So you can imagine what that actually means. With new annexes coming out from the FDA and others, we absolutely need to be in a dialogue. Absolutely understanding what AI will be introduced in manufacturing and process development will be key to stay in a dialogue. So at Merck, we classified smart manufacturing in 4 different streams or programs, and one of them is manufacturing excellence by design. So manufacturing excellence is quite known, but unfortunately this is a retrospect analysis and to optimize current processes. Manufacturing excellence by design is actually looking with the end in mind at the beginning. We're actually introducing R&D activities within the mind of having manufacturing at the end. IT/OT convergence, as I said, supply chain intelligence, and workforce readiness and change management. Those are the 4 big programs that are actually driving smart manufacturing at Merck as one Merck. In each of those boxes, we have every single sector represented, including IT colleagues. And how do we measure success? Well, when I was in the labs or in the manufacturing plants, I was always wondering, how do we actually introduce, when is the right decision made when you have a challenge? Like, I have a challenge with my OEE, with my overall equipment efficiency. How do we do? Like, usually you go and you do process design, you look into the manufacturing processes, you do manufacturing excellence, Lean, Six Sigma methodologies. But where is the digital aspect of it? So what we're introducing now is, while looking, and this is just an example, a KPI tree, which is pretty well known in the industry, and you have that in manufacturing. So if I see I want to reduce my lead time, that affects my OE throughput and my revenue, and with that my EBIT, I introduce a database that actually will tell you which smart manufacturing capability you may want to look at that will help you to optimize, in addition to your activities, your lease time. And on top of that, we are also introducing the business impact that you may have by introducing those smart manufacturing capabilities. This is based on benchmarks, internal benchmarks, by having done so already somewhere in the globe at Merck, or external benchmarks, so any peers that are sharing their experiences. Now these are, of course, just numbers. That's why we call it a compass. It's a compass giving me a direction. It's starting a conversation that we need to have anyways. And on top of that, we're introducing the standardized way of building business cases. We want to have one language every time we go into the investment committee. We want to make sure that we can simulate and predict the outcome of any capability based on standard assumptions, so that we can not only customize where needed, but we have an understanding of what the impact will be by introducing the capability in a plant or in a lab. So let me share with you some of those examples. So the digital twin. So we have started, of course, with not only foundational activities, but also exploring where possible, where we have a higher maturity levels, introducing new capabilities such as a digital twin. So, and this was another experience. I just learned that there might be a different understanding of what the digital twin is. I'm not sure what your experience is, but I had an experience that there was not a clear understanding. So we introduced a definition of what a digital twin is, and that's what you see here on the left hand of the screen. So, of course, it's somehow something connected to data, a physical object that is virtualized with a human-machine interface, connection, of course, to the model, to the data, and that model provides any service, prediction, for example. So, question. That virtual plant, is that a digital twin? Well, yes, it is somehow, but it's not necessarily super smart, right? That's why it has only 3.5 out of 6 of the score. The next one would be data mining, which is also somehow a digital thread and digital twin, but it still has only 2.5 out of 6. Automation might be, some cases, also a digital twin. But what we mean with digital twin, it's the lights of cognitive manufacturing. It's a full embedded, everything is included with all of those data, physical aspects, model aspects, and predictions. So let me give you an example. I'm sure that you are using, if not daily, maybe weekly, a digital twin. Any idea what I mean? Any digital twins that you're using almost daily? Cell phone, yeah? Google Maps, for example. So Google Maps, if you will, is a digital twin. It's a visualization of your reality around you. Is giving you real-time data, is having the model about predicting when you arrive, and even prescribing to you what you should do to avoid any traffic. And even more, it's connecting to other cars, to other equipment, and that is really giving you a digital twin to your hands, so that you, with a human-machine interface, you can build, or you can augment yourself while you're driving or walking. So if you think about that, that's exactly what we have in mind of a digital twin when we created that one. This digital twin here is a bioreactor, it's a digital twin for a bioreactor. Again, in that bioreactor we're producing, it's a manufacturing process step for producing antibodies with a mammalian cell line, so you have a biology piece on it. And with that biology has an own metabolism. You have this physical environment that has some complexity of shear stress and the other aspects, the physical aspects, physical-chemical aspects. So all of these models, mechanistic models, are quite known, and there are companies out there that can give you that models. Now what we're doing is combining all of these models and creating hybrid models with our own data sets and our own experiences, helping us to create a digital twin of that bioreactor process. Within 9 months, we have been able now to predict the titer, the outcome of the amount of product that will be coming, but we are also able to predict the cell growth. We are able to predict any kind of metabolism that is happening within that cell in that bioreactor, regardless of the scale. So that is amazing, which is happening already only in 9 months. And trust me, I think half of the time was about learning. So even more, we're continuing now because we're getting more requests. What happens if we can predict the quality attributes? So what happens if we can predict if we change the gassing, or a lot of different aspects? Our experts are coming to us, asking us, can we do more of that? That's exactly helping us to not only reducing those timelines, the drug to market or to clinics, but it's also reducing the costs that we are actually adding to the product, right? The cost of goods. But it's also sustainability aspects. Imagine how much waste we're producing. Well, it's not waste, but if we can reduce that, it is then, in that case, reducing or impacting our sustainability goals. Another the nice use case that we introduced is a so-called MTP, modular type packaging. So modular type package is a standard, basically. So if you're using your printer at home, you're connecting into computer, and I'm sure it's recognized as a printer. It's great. That's not the case in manufacturing. So as soon as you connect any kind of equipment to an IT infrastructure, there's a lot of configuration work that needs to be done. And that takes months. And as soon as you change and switch modules from one to another, it won't be recognized as such again. So you have to do a lot of manual work. And unfortunately, that equipment is not contextualized. So it's kind of stupid. So the MTP is the driver, if you will, to put on any kind of equipment so that everyone knows I'm a balance, I'm a pump, I'm a chromatography step, whatever I am. And that I can switch it in the way I need it, and I can even move them from one building to another. So that is exactly the beauty of using non-GMP material or equipment from a non-regulated environment to a regulated environment by adding the qualification validation step, but actually reducing massively the cost on the CapEx. The speed is amazing that it is actually offering us. However, regulators are still questioning, is this safe? So we are in the process of 5 years being in a dialogue with regulators that finally this year got approved. So you see, sometimes it is about understanding how safe also the environment is, and it requires a lot of dialogues also with regulators. As I mentioned before, supply chain is going to be key for us more and more. I think that this for the entire industry, as not being able to predict any demands, but also at the other end, you don't want to increase your inventory levels either. So how do you address that? And we have a lot of activities going on, especially also in electronics, with a program called Prime 1.0 and Prime 2.0, where we're adding more and more capabilities. A lot is happening also within healthcare and life science, so we're actually converging, getting together to actually share and know from each other how we can leverage those capabilities to rescale them. But it also links a lot of foundational work. So we started with 40 different ERP systems at Merck. That's quite a challenge. So to have this transition and introducing S/4HANA and more is one step, while you're looking at the other capabilities to be able to predict outcomes. So that's the convergence of different teams coming together and deciding how we do what. But it's absolutely crucial to be on one team. Otherwise, you get, again, different silos that you won't be able to scale. Introducing IoT and AI and models that will help us to reduce energy consumption in plants. We have been doing this already, scaled this across the plants, and we see a reduction of 20% of energy in manufacturing plants, which are now, we are having put into the roadmaps of healthcare, for example. They are now starting to implement this capability that we incubated in a plant and now are going to scale across. And last but not least, you see here an example how we're creating database business model as well with Atenia, one of the database business models you may also Google, that is actually providing data models to our external customers in the semiconductor industry to help them to understand their manufacturing processes. So actually sending us the data, we're not only cleaning them up, but actually creating our own knowledge and understanding how to improve manufacturing, but also how to understand deviations and quality disruptions in any product. So that's the model that works together in partnership with Palantir. and it's been showing a lot of value already, and the industry is picking up, and the semiconductor industry is picking up on this. And I'm very quite happy to pronounce that as well here, or to announce that here as well, because it's showing us that we are also moving into a field where we are actually, without any asset, if you will, it's the data asset that we're providing, the knowledge asset, creating new businesses. And with that, thank you for your attention. I'm happy to take your questions.